Hello there, Mr. Wilson here again for what is another video in this series on bridging the gap between GCSE maths and A-level maths. Now in this lesson we're going to talk about gradient. Now this is an absolutely vital topic for A-level because the way that you might calculate the gradient at GCSE, you build on that fundamental idea and sort of transform it into another idea that, in my opinion, is easier way to calculate the gradient, but without the skills from GCSE, that method that you learn just won't make any sense. So what I'm referring to here is differentiation, is calculus, which is a key cornerstone of A-level mathematics. Now, students who do GCSE further maths will be somewhat familiar with differentiation, but obviously they take it to the next level when it comes to A-level, and it is vitally important to know and understand the basic ideas of gradient. So let's jump straight into this video then by getting straight on with what is gradient. Well, gradient is basically how steep a line or a graph is at a certain point. So gradient is another word for sort of steep, how steep the line is, right? So the more steep, right, and I'm going to use inverted commas because it's kind of an informal word here that I'm sort of talking about. But for example, more steep would be almost like imagining like a hill, a greater gradient, that would have a larger gradient than that line, for example, right? This one has more, or a better phrase would be to say a larger gradient than this one. Yeah, because it's sort of more shallow, right? You imagine sort of walking up this hill. I would much rather walk up this hill than this one, right? This is way more steep, right? So it has a larger gradient. So that's kind of the very fundamental idea of gradient. Now, if a line slopes from bottom left to top right, we would say it has a positive gradient. And if it slopes from top left to bottom right, so it slopes the other way, we would say that this is a negative gradient. So far so good, right? Positive gradients, negative gradients, sloping up, sloping down. I like to sort of think of it as like almost like this is going uphill almost from left to right, and this is going downhill from left to right, so this has got to be negative. That's kind of how I remember it in my mind. Now, that's the very basic idea of what the gradient actually is. Now, we'll get onto this in a second, and this links to A-level maths, but the most common type of gradients that you will look at is on lines, right? So for example, you might be given a line like this, and they might say, okay, what is the gradient of that line? And there's a sort of very standard technique to do that, and I'll talk about that on the next slide. But let me just give you the other alternative. You might also be asked, okay, here's a curve of some kind. What is the gradient at this point here, let's say? Or what is the gradient between these 2 points here? Like this on the curve. And that's quite a common idea as well. So then, how do we actually go about calculating the gradient? Well, let me give you an example. So here's some questions picked out by Maths Genie. Fantastic questions, definitely check out his website. So here could be a classic GCSE question about gradient. It says the line L is drawn on the grid below. Find the gradient of the line L. So it's not asking for the equation. That's in lesson 4, by the way. We look at linear graphs in the 4th part of this video series. But for this 3rd part, we're just going to focus on that gradient. There are actually a couple of ways to calculate the gradient. Now, one way, especially on a grid, this tends to be quite a nice way of doing it. Basically, the definition of the gradient is for every one space you go to the right, how many spaces do you go up or down? Now in this case, if I pick this point here and this point here that are on the grid, when I go one square to the right, I go 3 squares up to meet the line again. So for every square I go to the right, I go 3 up. So the gradient must be 3, right? That's a really nice way of doing it on a grid. The alternative way, and we're going to look at this in a bit more detail in a second, the alternative way is to pick 2 points on the line. Okay, so let's say I pick this point and this point. Okay, let me just get rid of this for now. So this point down here and this point here. Right, you draw in a right angle triangle, so kind of similar to how we just did it. You calculate how many spaces you go across, in this case it's 2, and you count how many squares you go up, in this case 6. Now the definition of the gradient, this is a key fact, the gradient is equal to the change in the y, divided by the change in the x. So in this case, what I mean by change in y is how much does it go up by, right? Well, it goes up by 6. In 2 spaces across, the change in the x, 6 divided by 2 is 3, so the gradient must be 3. So either way, you get to the same answer. It doesn't matter what method you use, really. However, this one, where you use the change in y over change in x, that is a very key fact for A-level, because you then link that idea to what we call differentiation. So, with that in mind then, just have a quick go at this question. So pause the video if you want to look at it a bit longer. You don't have to necessarily write something down, but have a go at this question and just, see if you can spot what the gradient of this line is going to be. Okay, so hopefully you've spotted that the gradient is 2. Now you could have done it by saying that for every 1 square you go to the right, you go 2 squares up. And you could have alternatively done it by picking 2 coordinates, drawing your right angle triangle in, realising that it goes 4 up with 2 across. 4 divided by 2 is 2, so the gradient must be 2. So either way, whatever way you did it, you should get exactly the same answer. Now, if the line slopes downwards, as we already described at the start, we know we're going to get a negative gradient. So in this example here, if I pick 2 coordinates again, it goes 3 across and 3 down. So negative 3 divided by 3, because it's going 3 down, so it's negative 3. Well, that's going to be negative 1. So the gradient of this line is negative 1. So if it goes down, that's negative. And if it goes to the right, that means positive. If I was actually counting to the left, technically that'd be negative, but in this case the line goes to the right and then down. Now you can also get fractions for gradients. So in this example, it's a positive gradient. That's really the first question I always ask myself is this a positive or is it a negative gradient? In this case, it's going to be positive. Now, if I pick 2 coordinates, you go across 2 and up 1. Now, it's really, really tempting for students to then say that the gradient is 2, when in actual fact the gradient is 1/2, because you always do y divided by x. 1 divided by 2 is a half, or 0.5. Now, if you can't do the division, so in this case, I mean, technically you can do it because it's 0.5, but what I mean by that is, if it's not going to be a whole number, I just leave it as a fraction. And actually, when you get more into sort of understanding lines, perpendicular lines and all that kind of stuff, it's actually way easier to leave the gradient as a fraction than it would be to change it into a decimal. So my top tip recommendation would be to leave that gradient as a fraction, because it's going to make your life so much easier when you then go on to sort of parallel perpendicular lines and sort of deeper analysis to do with linear graphs. Okay, that brings us then on to what happens if you don't have the graph. Okay, what happens if you are expected to find the gradient between 2 points? Well, we basically do the same idea as what we've just done, we just don't have the picture to help us. Well, we know that the gradient is equal to the change in y over the change in x. Now, this is sometimes written as y2 take away y1 over x2 take away x1. Now, what this means is the second y coordinate of the two that you've got, take away the first y coordinate, and then the second x coordinate, take away the first one. So in this case, the second y coordinate is 10, the first y coordinate is 1, divided by 5 take away 2. Well, 10 take away 1 is 9, 5 take away 2 is 3, 9 divided by 3 is 3. So the gradient is 3. Now, if you didn't put the coordinates in the correct order, you might get a different answer. So if you didn't put the y coordinates in the right order, but let the x coordinates stay in the right order, then you get a completely different answer. So the order does matter here. In this case, where you're talking about the changing, it's always the second take with the first. Otherwise, you might end up switching them around and then getting the wrong answer because it ends up being a negative, or vice versa. So with that in mind, then why don't you give this one a go? So either have a go in your head, pause the video, write it down, or whatever you want to do, but have a go at this question and see what you can come up with. Okay, so you want to do the second y coordinate, take away the first one, divided by the second x coordinate, take away the first one. 0 take away 4 is negative 4, and that's why the order matters. Because if I put these the wrong way around, I'd actually get a positive 4 here, when actually the gradient is negative. Divided by 7 take away 5 is 2. Negative 4 divided by 2 is negative 2. So that is the correct answer. So the order is absolutely vital here, and that's why practice is really, really nice in mathematics. It just helps, sort of tidies up those simple mistakes that we can sometimes make. Right then, have a go at this one, but just be really careful with that negative and what's going to happen with that. So have a go at this one, give it a good go, and then we'll have a discussion in a second. Okay, so hopefully you did the second y coordinate, take away the first one, divided by the second x coordinate, take away the first one. 8 take away 4 is 4. That seems pretty self-explanatory. However, when you subtract a negative, that changes to an addition because it's a double negative. It's basically like saying, and this still, I tried to remember it, although this can sometimes confuse students even more. I like to think of it as, if you say, oh, I'm not going to play out with my mates, that actually means you are, because it's a double negative. So because you're doing a double negative, that then changes into a positive response, with the same idea in mathematics, that if you're subtracting a negative, that is actually the same as adding. So 5 plus 3 is 8. 4 divided by 8 isn't a whole number, but this can simplify to a half, so the gradient is a half. So, all really nice ideas, isn't it? Okay, with that sort of negative idea in mind, have a go at this one, see what you can come up with, and then I think there's one last idea I just want to have a look at. Okay, so hopefully you've had a go at this. So we've got negative 9, subtract negative 1, divided by negative 3, take away 1, positive 1. This top is going to be negative 9 plus 1. When you are adding a positive number, because remember 2 negative makes that an addition here. So if you are adding a positive number, this becomes less negative, so it becomes negative 8, divided by negative 3 take away 1, which is actually negative 4. Now, when you divide a negative by a negative, you get a positive. 8 divided by 4 must therefore be 2. So really, all grading is just making sure you get the right order, but also making sure we're really confident with those sort of additions and subtractions, multiplications, divisions with negatives. That is really, really important, especially this idea of subtracting a negative. It can be really easy to slip into a trap, and when you get an A-level question that's like 8 marks, and you make such a tiny mistake like this with the two negatives, or subtracting a negative, should I say, it is so frustrating, because the rest of the working out can't be right, and it's really, really frustrating when you spot that mistake to then go back and have to unpick all the working out and do it all over again. So it's really important to make sure these key fundamental skills are sort of in place. Right then, finally I just want to have a look at one of these questions. So this is a question where the gradient is given but not one of the coordinates. You have to kind of work backwards to find what the coordinate is. In this case, it's actually just the y coordinate of this second coordinate here. Well, actually, you just do exactly the same thing as you would normally do. It's just you're just using k rather than an actual number. So you do the second y coordinate, which is k, take away the first one, which is 2. Sorry, negative 1. even I nearly got it the wrong way around then, -1 divided by 6 take away 2. But we know that this must be equal to 5 because we're told the gradient is 5. Right, so that's the key difference here. Well, 6 take away 2 is 3, and k subtract -1 is actually k plus 1. So let's change that. K plus 1 over 4 is equal to 5. Well, to find what k is, we have to do the opposite of whatever it says. So I'm going to times by 4 because it's a divide by 4. So k plus 1 is equal to 20. So k must equal 19 because you subtract 1. So k is 19. So this actually incorporates a little bit of solving equations with where's my train of thought going? Solving equations with gradient. That's where I was going. Right then, I think I'm going to wrap it up there for this video. This video has been a little bit shorter than the other ones because I think I'm going to sort of go more in depth when I talk about linear graphs, which is what the next lesson is on. I really enjoy making these videos. I think it's really important that we make sure those key skills learnt at GCSE are sort of embedded in the foundations of your maths, because it'll make your life so much easier. I've been there, I've worn the t-shirt, I've done the A-level in maths, and I was actually the last year that did the old A-level, which isn't as difficult as the one now, but even so, it was so important making sure you got them sort of basic math skills there for when you actually study the A-level, because it can be quite intense sometimes, and it's always really important to look back on what you already know and sort of build on that and sort of extend what you already know, rather than forgetting everything that you know and trying to learn everything as almost if it's from scratch. That's not a very good idea. Anyway, I hope you've enjoyed this video. If you have, definitely let me know in the comments. I know that there are a few people that I know who watch these videos. I've actually found them really useful because it's, you know, something that they're preparing for September. So if you've enjoyed this video, then definitely check out all the other videos on the channel. Subscribe if you haven't done so already. And all I want to say is thank you so much for watching, and I hope you have a fantastic day.